Fred, is this color?
Sam, your name is not on this, minus 5 points.
Oh.
Is there one you prefer?
I feel like it's not that hard to figure out which one's Sam's because it just has the big handwriting.
Thousands of papers long. Each question is about.
I also
4 pages.
didn't print off the first 3 of mine.
Yeah,
Oh, I didn't print out the questions.
mine was 11 pages. I found out I have $138 worth of printing funds though.
From what?
Oh my God, give me some of this printed
Yeah,
money,
why
dude.
So what textbook do we want to
That's-
print?
We have like hundreds of thousands of pages you can print out.
I've used almost half of my.
$15 is about 500 sheets of paper.
Really?
That's the fact I'm told. to tell our
Yeah,
board.
that is accurate.
That's right.
Yeah, it's 4,600 pages worth of paper. that I
Never print copies of the copyrighted textbooks. I strongly discourage you to do so.
Yeah.
Yeah.
Oh, now that he's not here, I can say, Gudong. He would never require a textbook for the class.
If you're going to say something sensitive, I need to switch off the microphone.
Well, no, he's not here anyways.
But let's follow the policy publicly and officially discourage each other from.
Yeah.
Yeah. Discourage each other, everyone.
Yeah, don't print off the textbook, Ava.
Yeah.
Don't print off the textbook, Sam, with all $130 of printing money that you have.
Can you like transfer that? into-
Bro, I wish I could transfer that into
Campus
my
cash
pocket.
or
That'd be
something.
great.
On real
So,
space.
Somebody else made.
It's a lot to go,
So I guess I have to-
So on Monday, you are presenting,
Oh, yeah.
right?
Yeah.
Can't wait.
And maybe
Are we going in order?
yes, Sam is number 1.
Yeah.
If they like.
I'll start Frederick, me, Melody. I love
Okay,
it.
so Sunday night, please send your PowerPoints to me and CC to, I will give you emails of the helpers. They look,
Okay.
okay?
Yeah.
I will be not here, but I will watch recordings.
Yeah, where are you going again?
A suburb of New York.
Ah.
That's gonna be nice this
that's
time of
cool,
year.
Yeah,
You get out of Florida, you get to go to
I'll go
NY.
anywhere.
So this is too much. Let's be a little less generous, put 30 here. Otherwise, one can get AAA only for doing math. Okay, so.
I like that.
First one, I didn't print the assignment, but you need to do commutation, right?
Yeah.
Commutation of X and derivative. Correct? And did you got 1?
Yeah.
Yes. And if the meaning of this, like the derivatives cancel.
X.
Huh?
Oh, never mind.
So just grade, if you see correct answer, give full credit. If you see correct, have a thinking and some little errors, give partial credit, give generous.
Uh-oh.
My pen's not working right there.
But
Sorry.
you have 100 other pens, right?
100.
I do have 100. Thanks for these, Sam. Gosh, you're a real one.
Yeah.
I'm still kind of not great, but sorry.
So
Very hard.
the meaning of this exercise that by swapping the order of derivative and position, like here they are swapped. We are applying derivative here to the linear and here to the quadratic. And the result is will be non-zero, right? If one places the correct coefficients in front, x position derivative is the same as momentum, and if one finds commutation of position as momentum, the result will be Planck constant. We have already used it and we'll keep using it. Okay, we will assign this 10 points or 9 points if there are any errors, right? Okay, let's keep going. The quantum cookbook. It's just to go quicker. You are giving me.
Oh, no.
That's
I'm
okay.
like cooking, I'm
Oh,
cooking.
okay.
Cookbook.
So just copy paste, right? If you have initial condition, you create expansion coefficients and plug them into the summation of all eigenstates. So if you see it, you give another 10 points, and eigenstates and eigenenergies for the phase accumulation. I know you hate this word, right?
We hate this word?
You hate the word phase accumulation.
Oh, yeah, we did, I
So
remember.
I remember from the past, you all did correctly in remembering equation, but you hate verbal description as because the phase of exponential is changing and it grows with time, so it accumulates.
Yeah.
I don't insist, I just like this term. And this energies come from the time independent Schrödinger equation that Patricia, we discussed it recently, right? So problem number 3, I think I do have a, just give points there. So it was 20 points. So suppose we know the wave function, the Gaussian exponential centered at x0, and there is an unknown normalization factor. So we need to find where this wave function is centered to practice this bridge between abstract theory and the real world. And in order to do so, one first needs to find the value of the normalization factor. If it is off, if it is wrong, then all remaining answers will be wrong. So when I was doing it, the normalization factor was square root of 2 over pi. If anyone has it, where it's generally.
Generously?
Pretty generously anyway.
Yeah.
All the time.
Oh, I'm a strict grader for friends' work.
Do you see the right normalization? Someone did, right?
There's, yeah, there's information.
Okay.
There's
And
something.
this interesting thing of square root, we will see it in about a month from now, when we will be doing quantization of vibrations in molecules. This square root will pop up again. So it is when you normalize Gaussian wave function, it happens. So how does one? My answer key is dirty. I accept it. The way to get this n, you just integrate Gaussian, and you want to identify e to the power minus y squared, right? And to do so, one makes a couple of substitutions. And by making the substitutions, one arrives to the Gaussian integral, which gives the answer of square root of pi, right? This square root of 2 comes from changing variables, because when you take square of the wave function, you get this 2. And then by solving like n square equals square root of pi over 2, you get this answer. Now to find the expectation value of position, you do wave function conjugated wave function itself, but since it is real, there are no complex parts. You just wave function squared with this factor 2. And this integral is very doable. You can just submit the x under differential sign d. Differentiation signs. And then if you see this or similar mathematical tricks with assign partial credits, so the
Thumbs up then.
also one can change variable x minus x naught as new variable, and here. Before going under differentiation sign, is changing the variables. Either instead of linear of the independent variable, it becomes independent variable plus constant. And then we have two different integrals. One has the exponential times constant, which will be just Gaussian integral, right? And another will be Gaussian times linear function. And we can call them zeros power and first power. Make sense? Okay. So the integral is the first power where Gaussian is multiplied by a linear function, can be graphically represented as positive and negative sign, right? If you multiply the peak by a line, it will line some is part of its life, it's positive, parts it's negative. It transfers sign to this function, and upon integration, you'll get equal contribution of equal parts, and it will be zero. So I1 will be zero, and for I0, 1/3 machine. Okay, and for zeros order, one just changes variables in such way to have only Gaussian integral, and then as a price for this trip, one needs to pull some factors up front, and one has this x naught from our original settings, right? So if one integration gets square root of pi over 2 over square root of pi, they cancel, and the answer is x naught. So the Gaussian wave function centered at x naught will give expectation value x naught, which is intuitively clear, but one needs to prove it. I'm curious how your grading is going.
Yeah.
I just enjoy my entertaining program.
It's going.
So what's which points did you notice in what you grade? How many points did you assign?
Well, I got the 2 pi to like double square root or to the power of 1/.
Okay, normalization.
Yeah.
And what about the integral? Did the one whom you grade what x naught?
I think there's like parts that are
It's,
following and.
so just do like each line, do like plus one,
Okay.
and please accept my encouragement. Okay, but give some points. I know that I.
How many is this out of?
Huh?
This is
40.
This one question is.
This one question?
What was question 2 out of?
Okay.
Wait, whoa. Question 1 was out of what? 10
Question 1 was 10 points, question 2 is 10 points,
Yeah.
question 3 is 40 points. Well, because it is heavier mathematical, right?
I'm having a really hard time.
And I'll probably collect works this time just to enjoy and see how perfectly you grade each other.
Okay. Do you want 8 or 9 points then? How about like, can I do half? Half
What do you mean?
a point? Like 8.5?
Oh.
Or could I just round up? to
Round
9?
up to the top. Be always generous.
Okay.
You can even round up to 10.
Okay. Okay.
So everyone is done with this. Question?
Sure.
Yeah.
Okay.
Yeah.
Provides.
Okay, next one, also 10 points because it is simple, just reproduce the equation how the product of uncertainties develops over time, right? And if there are any errors in factors, just forgive them. Give full credit if you see this parabola, or if you see this constant plus time squared.
Yeah, I got it.
What's this out of 10?
So the meaning that uncertainty of position times uncertainty of momentum is bigger or equal than a constant with but this escalating factor, because packet becomes broader and broader. We did prove it for particle in a free space, but there are ways to generalize it to any problem, and philosophically it's always correct. Okay, done.
So, okay, wait. So the answer tone doesn't increase, can it?
It can decrease. If we start at any possible time, if instantly we decide that, oh, okay, I designed a time machine and I want to go backwards, it still will increase. Or whatever we start at, if you go forwards, it will always increase. So for this problem, there is no way to make uncertainty smaller. There are some other problems with tricks about uncertainty, but it will be too much to focus on them. Okay, done?
My pen's having a really hard time today.
Pick a new pen.
Well, I already started.
Okay. So the problem 5, 30 points. Do they add together 200? 10, 10, 10? Yes, yes. This just to round up to add total 200, I put it 30, but maybe next year I need to reconsider. This one is also mathematically it's not heavy, but philosophically it is heavy. And this problem is the foundation of our next 3 weeks. I brought a book and put a bookmark there. So it is a very simple book for like low-level colleges. You guys are.
Oh, that's what we need.
No, you are already intellectually elite. But if you want to, but if you want to see what like low rank colleges are learning, you can look at the place where a bookmark is, and never use your print quote to
Yes, Sam.
copyrighted materials, right?
Right.
So
Sam, shut up.
so here is the problem
I got a spoon, got some strap.
that you were doing, and hopefully you got success and you give perfect ratings to each other.
Yeah.
So who is taking differential equations? Huh?
Taking it right now.
You've already taken it though.
Okay. So this class in narrows from one angle point of view. Physical chemistry just applied differential equations, or differential equations applied to chemistry, right? So what the differential equations are foundation. When we skip non-linear differential equations as much as possible, so looking only on linear, maybe even first order, but system of many, and generally. There are, please help me, I forget it all the time, terminology. There are general solutions and specific, particular, okay, particular solution. So we need to match particular solution either to initial condition or to, when I took in my sophomore year differential equation, this terminology was there, and I think it is over the world. So to specify, to find, to solve for particular solution, one needs either initial condition or
Final.
you get A++ in philosophy.
Oh, okay. Well,
It's a little bit different from the differential equations, but philosophically he's correct. If there is a start, there is an end, right? And if our independent variable is not position, but like time, well, if it is time, that's initial and final. But if it is position in space, then there is like beginning and end at the same time. And our wave function is in between initial and final. And if you suppose you have a country on the map.
doing geography now, all right.
Yes, yes. And when a country goes from here to there, and how do you call the things that restricts
The
the
borders.
Yes.
Boundaries.
boundary conditions?
Yeah.
Okay,
Oh,
So
yeah.
you need to match boundary conditions.
Which is what this question is.
Exactly. So, suppose we have a general solution in here. So summation of sine and cosine with unknown period and unknown amplitudes. But we do know that this wave function is as an argument of x has a boundary condition. When x equals 0, it is 0. When x equals L capital, is also 0. And the task is to solve for A, B, alpha, and beta. Right? And it is what I hope you all guys did.
Good job.
So please all the phrase. So we just plug in values of argument at boundary. If x equals 0, we plug 0 here. Then the sign of 0 is 0, cosine of 0 is 1. And then we have an equation. B times A times 0 plus B times 1 equals B on one hand. On another hand, it must be 0. Before, so if so B is 0, we already solved for one thing, right?
Yes.
And if we solve that B is 0, then we don't care what is beta. So we need to solve only for A and alpha. So give partial credit for if you see this step. If B equals 0, give whatever, right? 10 points, you decide better.
Okay.
No. Next step, we plug the next boundary. When the argument equals L capital, we have amplitude times sine unknown period times L. And we do know that at this boundary, B wave function equals 0. So the A can be removed for now, and then we need to solve an equation. Sine of unknown frequency times L equals 0. So you just draw a sine and look when it hits 0 axis, right? When the argument equals pi times integer, correct? This is very simple, but it is a foundation for 3 weeks from now on. So you all do, I think you see the solutions in your work and you give partial credits. I'm just like to speak out loud. So if we all believe in this equation, then we can solve for alpha, right? Divide left and right by L. And then alpha is n natural number integer times pi divided by L. And then where n is can be 1, 2, 3, or -1, -2, -3. Okay, then our wave function by now is we solved for that B equals 0, beta doesn't matter, and we have only unknown A capital. So to find for A capital, we need to normalize. So wave function squared integrated in the area of definition must be equal to 1. So if this is our wave function, we have A squared, then integral of sine square of this argument. You take the integral, it's a little mathematical task. And after getting the answer and taking square root, one should find that A is 1 over L. So we have the square root 1 over L sine. So I think beta is irrelevant, so let's do 10 points for B, 10 points for alpha, and 10 points for A capital. So if everything is done except A, then it is 20 points. Okay. Done with grading, or you need?
I'm done. You may move on.
Okay, thank you. So, and for the this thing, I'm not showing it. That gives me a little breathing space to grade next year. But the problem was for extra credit was to integrate sine x times sine 2x dx from 0 to 5 or something like that. Yep, right.
Yes,
And I don't remember the answer, but it should be
-8 over 9.
That's what I got.
8 or 9.
Not
No,
square.
it's not square rooted though.
No square root?
No,
Okay.
there's -8 nines.
Okay. Okay. So if the answer is not correct, but you see the steps, you see that one tries like this UV minus V du.
I did that.
If you see it in even with the wrong answer, give partial credit. Okay, now
It's implied.
please add together all numbers, write them on the first page, and divide by 100.
We get a percent.
Yes,
You want it or you
Yes.
want it in percent form or fraction form?
whatever. I can use calculator. And now you see that if the one whom you are grading has missed some of the main tasks, this extra credit will compensate, and there is still a chance to get 100%.
Wait, I got more than 100.
Yeah,
Or should I get
Yes,
for the extra credit one?
Yes,
Okay.
I just I really wanted. I'm going to collect. Do not return it to the.
What if they want to see it?
Oh, he wants to bribe you for a beer.
No,
That
I'm-
goes the other way.
I'm proud of it.
Oh,
Thanks, Sam. Wait, what, is this out of 140?
No, it's out of 100.
Because one of them is extra credit.
exactly.
Sorry, Elsa.
I'm
Got
frequently criticized by colleagues, like, how can you get A for everyone in the class?
Because it's small.
No, because they are intellectual elite, they're so smart.
For emotional support. That's not mine.
Yeah, where's that cat, Elsa?
Oh, she brought him home.
Bobby.
Okay,
You want it back?
I plan to bring it back, just enjoy.
Wait, Sam's name isn't on that one. It's on the other ones.
Just have like a billion pages.
Okay.
Sam has many pages.
Fred, how did I do?
Sorry for like.
You're pretty good, I guess.
Yes.
And what's it?
I don't know.
Is it something?
Oh, these are just.
Still got
The rest of
details.
Sam's novel.
Hmm. Is that what you call it?
Okay,
Yeah. Top love.
I'll briefly glance.
Oh, is it? Schrodinger's cat.
Is it hot as hell in here? Or is it just?
Yeah, it's warm. But I'm in here.
I'm cooking.
I am comfortable because the room that I was
Okay,
in before this was like
I-
outrageously warm.
All approved, you can take it back.
Okay.
Okay.
So successful completion of the whole.
That's not yours, that's Fred's.
But, I think, although you all
I guess.
get, A plus, I hope you're developing right,
He's proud of me.
so I think you're developing an attitude to still do projects rather than exam.
Yeah,
which would
correct.
Consist of such problems.
Yeah, Elsa already voted.
Yeah, I already voted.
I would like to cut
We
my vote,
unofficially- yeah, I'll
same as Elsa, project please, no test.
I agree.
Okay,
Fred agrees too.
Then I can teach you all about my raspberry.
that's great. So we have, oh, generous 15 minutes.
It doesn't matter because it's a vote, right? So if we have a majority, then it doesn't
Does
matter.
it have to be a unanimous vote?
Does
Or majority vote?
So,
Well, if.
Well, Fred can
yeah,
take the
we'll see how it
exam.
can be.
Fred, yeah, Fred, you can take the exam, no one,
I'm good.
Oh.
alright, I'm just gonna,
I know, what? Did you see my note?
you suck.
Yeah.
I'm going to cut holes in all of your socks.
You wrote loser on mine last time. I don't know where you did.
I always knew that you are good friends of each other. So I do have some slides, but maybe let's chat a little bit in freestyle and maybe
Oh.
slides will go in the.
That lands.
So, slides can be done next time, or
Yeah.
if you're tired to chat. So, chapter that we are studying is called particle in the box. And I'm really happy to see that Patricia is so attracted to this book. But if you let it go around and just glance on this,
At
on
the
this chapter.
bookmarked page.
yeah, where the bookmark is, you can just flip through and
Just look around.
on the figures, yes.
Okay.
So, we have completed the basic principles, some very, very introductory theories, and did apply them to the simplest possible problem. Electron in the free space. We need to move on toward more practical systems related to chemistry. Now, chemistry, as I was taught in middle school, is a science of molecule. So you all are trained chemists. So what is a molecule? Just philosophically defined.
Composition of elements to make up a.
Good.
To make up a compound.
Okay, but if you have anion, cation, radical, can it be considered as molecule as well?
No. Yes, actually. it is,
Molecule,
yes.
molecular system.
Molecules are everything, but compounds have to be made up of 2 or more elements. That's right.
So right now, we stand on the foundation of our introductory quantum theory, and we know that electrons are everywhere, right?
Yeah.
So the elements as
The textbook.
did you watch the TV series Apple TV series?
No.
It's a
Agreed.
world where after global collapse, the whole humankind lost ability to see, and there is a civilization of blind people, and they just
Oh,
Echolocate?
echolocate, smell. The queen in one of the countries has like hand rings with little bells, and when she needs someone to approach it, ding, 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 ding. Yes, yeah. So the
True false.
molecules have electrons, right?
Are we getting to the wavelength like stuff?
No.
Damn, I saw it in the book, that's why.
Much simpler. If we remove electrons from an atom, or from like all electrons, what do we have?
Cation, negative, positively charged.
Okay, perfect. I need to focus camera on you, not on me for this.
Yeah, I can,
For me?
Well, all of you guys, if you.
Oh, yeah. That one or this one?
According to a certain journal, I'm a doctor.
So,
Yeah. That's what her.
positively charged ions, negatively charged electrons, right?
Yes.
Yeah.
Right. So, the ions, if the molecule is intact, the ions are quite close to each other, right?
Yes,
From some bond length distances.
yes.
What do electrons when they, if you like remove all electrons and then throw them back to the molecule? What do they do?
They just get back into the shell and neutralize the.
Exactly.
cation, the positive.
Yes. And if you look from a perspective of space, do electrons like to stay near positive ions, or they goodbye parents, I'm going to my own life?
They like to, they tend towards molecules that are closer to a full valence shell, whether that is getting rid of or accepting.
This is correct, and it's too smart for me. Just generally, the ions, the electrons tend to be near the ions, right? And they do not like to be away from ions. So if you have a size, if you know approximate size of the molecule, we can say that electrons will stay only in this range. Like before our four electron was really moving across the whole universe. Now, if we slowly and approximately move to the molecular road, we know that there are areas in space where electrons like to stay. Everyone agrees?
Yeah, told us. I would agree with that statement.
Okay, yeah, thank you for supporting. So let me go a very silly, but hopefully deep figure. So before we have the coordinate, potential energy, and it was trivial. The energy as function of position was 0. So for free space, V of x is 0 everywhere. Okay. Now, suppose we did create a molecule. We're very far from true chemistry, just any molecule, which means we have placed at certain positions like x1, x2, the attractive potential. Like maybe it is H2 for two attracting centers. And then the electron will decide either to stay here or there, or maybe if the potentials are shell, it can be in between, forming a bound, right? But we do have the range where the electron likes to stay and the range where it doesn't like to stay. Agreed? Now, if we apply this vision to atoms and small molecules, it will be so much wrong that we will decline. But if you have a big molecules or even chunks of solids, then this approach will provide answers very close to real experiment on one hand, and on another, it is the simplest possible quantum problem. Because in some sense, you already solved it as a question number 5 in the last homework, right? So I am going just to mumble and draw some diagrams to convince you that what you did in question number 5 is a good foundation for next things to do. So suppose we have more than two atoms. Suppose we have like many atoms collected close together, maybe a linear molecule. If we look on this potential function position from with a bird's eye. And once I was one of the students took this word as an offense. I thought bird's eye means like we are like eagles, look from the top and see the big picture. And the student thought, bird's eye, you think I'm stupid like a bird?
Oh.
No, we all are smart like eagles. So if you look on this diagram as a bird's eye, there one can approximate this diagram, just neglecting the fine structure and looking at it as a little box.
Yeah.
So there is an area from x equals 0 to x equals L capital, where potential is negative something, and everywhere else it is 0. Do you take this argument?
Yeah.
Okay, and basically this is the problem that we are going to solve. We are going to design this square box potential, and we are going to place an electron there and see what it does, both in space and in time. Now, which systems are convenient, are appropriate to describe by this model? Please give some guesses, some suggestions. Just volunteer imagination. Which real world molecular systems can be treated by this potential? And go ahead, don't hesitate. Who is working for us?
Conjugated polymer?
Yes. Do you see it?
Nailed it, Elsa.
You
Yeah,
see- you do or you
We've
don't?
I think I
never
get it.
talked about conjugated polymers in a class though, so I don't know if they would know anything about them.
Hmm?
We've never talked about conjugated polymers in a class though.
Okay, but why conjugated polymers are good to describe by this model? And what are conjugated polymers?
Is it because you have with polymers, it's just endless chains and you have like repeating double bonds or triple bonds throughout it?
Music to my ears. I'm pleased to be surrounded by highly educated people.
So would your L basically be your N for polymers when you have like the brackets? Well,
You need to teach this class.
I'm so smart.
Yeah, you're so.
So, yeah, we have 2 more minutes for jokes. What is the political system in this country?
Two-party?
Oh,
Democratic.
Two-party?
Sort of.
okay.
Were those not correct?
So some of you call it democratic. Like historically in medieval ancient times,
Monarchy?
monarchy.
Oh,
Okay, and monarchy is like there is one monarch,
yes.
king,
England.
queen. Yeah. Democracy is like many people vote and decide thing. And in between, there were, if you like look through history, or sometimes journalists blame powers in any country, if there is a corruption and the decisions are taken not by a single leader, but a handful amount of influential people. Not single, but several.
Okay.
And sometimes it is used as a negative word. So monarchy, mono, single.
Polarchy.
Oligarchy.
Yes. He's ready to teach this course. Repeat it, repeat it.
So good today.
The oligarchy,
Yes.
right?
You hear it?
Oh,
Yeah.
like the,
Okay. So
I
now
knew where you're going.
for again, you need to correct me because switch for the microphone. I'm not a chemist by education. But if you have, let's see, something like this, carbon, single, double, right?
Yeah.
Yep.
Yeah,
And then if you do this. So
Yeah.
this can be called polymeric people should.
Wow.
Well,
No.
I don't care about exact chemical name, but you see this unit.
In oligomer? Is that the word you're looking?
Yes, so, but oligomer is like here n equals one, n equals two, n equals three. If it is n equals one, it is same as monarchy.
Monomer.
Oh, yeah.
Monomer, dimer, trimer,
Yeah.
and if there are n, but not, if n is less than infinity, is a oligomer.
It's in.
Now, if you create, there is a, more and more little dips, because there are more and more attractive carbons. Right, and we can approximate it as boxes. Small box, wider box, even wider box. Right, so the electrons move within the box.
Yes.
I think, I was so excited that I wasn't focusing on the board, like here are the things, if you open the recordings.
Okay.
So meeting is done. We can, looking forward to see you tonight at,
Yeah.
Yeah.
and you can
Yeah.
do
This in MATLAB?
Huh?
Are we gonna do this in MATLAB?
Oh, yes.
Yeah.
Oh, yeah.
This is actually interesting.
Yeah, that's.
Oh, I told you.
This is actually.
Oh,
What do you
like
think about the class?
Well,
Brett?
I mean, all these, derivation equation.
A lot for your brain to handle.